Hello, welcome to Pre-Cal Lecture 4.1, which is the Introduction to Exponential Functions. You've got pre-printed notes for this one, so let's go through it. All right, section 4.1.1, we're going to talk about standard form of an exponential function, and that is y is equal to b to the x, where b is a positive real number that is not equal to 1. Okay, so the thing that you need to really remember the most is that your variable is an exponent. Okay, so the variable is an exponent. So I've got some scenarios here for this next example, and the question is, which of the following are exponential functions? So do they follow the rules? And y equals 2x squared would be no, because the variable is not an exponent. We've got a 2 there, so that's not an exponential. How about y equals 2 to the x? Well, that one is a yes. That's a classic exponential function. It follows the rule for the base. It's a positive number not equal to 1, and you have the variable as an exponent. How about y equals 1 to the 2x? Well, that's no, because the base, b, can't be 1. Okay, how about y equals negative 2 to the x? That's also no, because b has to be positive and it's negative. How about y is 2 to the minus x? Well, the exponent can be negative. The base follows the rules, so that's fine. And how about y equals 1/3 to the x plus 4? Okay, that's also fine. That answer is yes. It's not 1. It can be a fraction. It can be a decimal. Just can't be 1. And you can have, as long as you have the variable as an exponent, you can add or subtract from that variable or multiply by that variable. So that's some examples of exponential functions and non-exponential functions. All right, so 4.1.2, we're going to be evaluating exponential functions. So this will be kind of a review. Remind you how to deal with them. So you've got a big blank page on your notes, so we're just going to give you a bunch of examples. So let's say you have f of x is equal to 3 to the x. What is f of 2? So that's going to be 3 squared. You just plug in 2 for x, which is 9. All right, so start out with a super easy one. Next example, let's say f of x is equal to 4 to the minus x. Let's find f of 2. That's going to be 4 to the minus 2, plugging in 2 here for x, which would be, if it's negative, that's the same. We can make it positive. Remember from our exponents in chapter 1, that's the same as 1 over 4 squared. We can make that exponent positive if we move it to the bottom, which would be 1 over 16. All right, let's say f of x is equal to 25 to the x power. Let's find f of 3/2. Well, that's going to be 25 to the 3/2, and we could rewrite that as the square root. Remember, what goes in the crook of the radical is in the denominator of 25 all cubed. So square root of 25 is 5. That's the same as 5 cubed, which would be 125. 5 times 5 times 5. All right. So we've got more to go. So hopefully you've left some space for yourself. If not, you can always go to the back. All right, so we're still in that area on page 1 of your notes. Let's say that we have f of x is equal to 1/2 to the x. Let's find f of -3. So that's going to be 1/2 to the -3. So the long way to do this, which would be, and I'm going to show you the short way, but 1 over 1/2 cubed. That's 1 over 1 cubed is 1, 2 cubed is 8, 1 over 1/8, and 1/8 will go into 1 8 times. So that's the long way. But you could also rewrite this. If you flip the fraction, you can make the exponent positive. So that's 2 cubed, which is 8. So that technique is really handy and could save you a lot of time. Okay, so last example. So I'm at the bottom of the first page. Let's evaluate, say f of x is equal to 2/3 to the x. Let's find f of -2. So that's going to be 2/3 to the -2 power. And I'm going to do the shortcut here. That's the same as 3/2 squared, which would be 9. 3 squared is 9, and 2 squared is 4. So that'd be 9/4. Okay, that does it for the first page of your notes. The rest of your notes is really just going to be drawing some graphs and talking about how exponential graphs look. Okay, so 4.1.3, we are at the top of page 3, and I've got a lot of empty space there. So our example is graph f of x equals 2 to the x. So let's do a table here. We've got x, f of x. So let's say x is -2. That's going to be 2 to the -2, right? 2 to the -2. That's the same as 1 over 2 squared, which is 1/4. So f of x is a fourth. How about -1? 2 to the -1 is the same as 1 over 2 to the first power, which is 1/2. How about 0? Well, 2 to the 0, anything to the 0 power is 1. How about if x is 1, 2 to the first power would be 2. If x is 2, 2 squared is 4. And you go on and on. We've got a table of values here, so let's see what this graph looks like. I've been drawing a lot of graphs lately. So let's say, let's go 1, 2, 3, 4, something like that. Let's go 2 tick marks to the left, 1, 2, 3, 4, 5, 6, something like that. Okay, we know we cross the y-axis at the point 0, 1, so right here at 1. And then we've got 1, when x is 1, y is 2. X is 2, y is 4. And then when x is negative 1, it is 1/2 and then 1/4. So an exponential function looks like this, 2 to the x. Okay, so I didn't really hit the mark on that one, did I? So there we go. Okay, something like that. A function that starts out to the left of the x-axis, increases very slowly, and then just rockets upwards. So when someone says, hey, that is increasing exponentially, they mean something that is just, as time goes on usually, the function just rockets upward. Okay, so that's your basic graph of the most famous exponential function, which is 2 to the x. All right, we are in the bottom half of the page, and we're going to draw a graph, and I'm going to draw how changing the coefficient will change. So let's do a nice big one, big graph there. All right, let's go 1. And if you have different colors, that might help. Let's start out with y equals 2 to the x. Okay, so that crosses here at 0, 1. And then when it's 1, I have 2. When it's 2, it's 4. When it's 3, it's let's see, 1, 2, 3, 4, 5, 6, 7. It'd be way up here at 8. Okay, so that's y equals 2 to the x. So what happens if you were to graph y equals 3 to the x? Well, what 3 to the x does is makes the whole thing closer, still crosses at 0, 1, but it increases even faster. So y equals 3 to the x would really be rocketing up. So if you increase the base, you're just causing the function to be even more exponential. Let's say 5 to the x. I mean, then it's really smoking. So y equals 5 to the x is green. So you can see the larger, so I wrote this in the box to the right, the larger the base, the more quickly the function grows. For positive values of x, and the more quickly it approaches 0 for negative values of x. Okay, so go to the very bottom bullet here. If the base is between 0 and 1, the function can be rewritten with a negative exponent, reflecting the graph across the y-axis. Okay, so let's draw 1/2 to the x. Okay, so y equals 1/2 to the x would look like that. Because that's also equal to 2 to the negative x. Those are the same thing. So it reflects it across the y-axis and goes the other way. Of course, we're reading, it comes down like that, right? So the graph, you read left to right, and it's coming down. As x gets more positive, the graph gets closer to the x-axis. Okay. So let's write that down if you have. As x gets more positive, y gets closer to the x-axis. This is just for when x is negative. Okay, so when x is negative. It does the opposite of that when x is positive. Okay. So let's go on to the last page of the 4.1 notes. And we're going to just do two basic graphs on this page, and then we'll be done with section 4.1, which is really just an introductory lecture. Okay, so we want to, what we'll call, add to x. And the rhyme is add to x, go west. All right, which west is just left. Okay, so let's do a coordinate plane here. X, y. We'll make some tick marks here. Let's do y equals 2 to the x. So when I add to x, so let's say y equals 2 to the x plus 1, it shifts the entire graph left. All right. So the green here is y equals 2 to the x plus 1. So the entire graph is shifted left. Okay, so add to x, go left. So we added to the exponent. If you subtract, it would go right. Okay, so it would do the opposite. And then finally, the bottom of the page, we have to add to y, go high, which just means go up. So let's say that's y equals 2 to the x. What I have in, I'll do this one in red. If we add to y, what do I mean by add to y? It moves the whole function upward. So this would be y is equal to 2 to the x plus 4. So I'm not adding to the exponent, I'm adding to the entire equation. That plus 4 is not part of the exponent. So that moves the whole graph up by 4. If we subtracted 4, it would move it down by 4. All right, so that does it for this introductory lecture. There is no homework for 4.1, although you will use this information in future homework. So that does it for lecture 4.1. I'll talk to you on the next one.